The next topic we have in reflection is the reflection of a point in a line. Okay, so here we have a line AB and we are going to find the reflection of this point P in this line. Okay, now tell me, if this line was a mirror, okay, let's assume this line is a mirror, where will the image be formed? The image will be formed behind this mirror at the same distance as P is, right? So what do is we just take the scale and we draw a perpendicular from this point onto the line AB, and we let it cross AB and take it to the same distance as it is from point P. So this point P dash is the image of this line AB in of this point P in this line AB. So the definition says that image P should be that the reflection of a point in a line is such that the line formed by the image and the point, that line is P dash, should be the perpendicular bisector of AB, and they should be at the same distances. Okay, so this should be the perpendicular bisector. This is what the definition says. You write the definition in your own words, and the definition says that the point and the reflection of the point, the line joining the point and the reflection of the point, should be the perpendicular bisector of the line AB, the line in which the reflection has to be taken. Okay, the next we have is invariant point. What is an invariant point? Invariant point is a point on the line AB whose reflection will be that point itself. Imagine that there is a point, let's say this point D on the line AB. What will be the image of this point D in line AB? That will be this point D. So the image and the point coincide, and that point is known as the invariant point. Now remember that. Okay. The next what we have is, I've just drawn this Cartesian system over here, xy coordinates, and we will find the coordinates of a point, of the reflection of a point in x-axis. Okay, let's say that we have a point P over here. Okay, we have to find the coordinates of the reflection of this point in x-axis. How do we do that? How do we do that? We remember the rule for the reflection of point in a straight line. X-axis is a straight line. So we just take our scale and we draw a perpendicular bisector, right? And we just extend it downwards. We just extend it downwards and we take it to a distance that is equal to this distance. Okay, this is P dash. This distance is equal to this distance. Okay, so if the coordinates of this point are, let's say, small x comma small y. If P is small x comma small y, so the reflection of P in x-axis is equal to P dash, that is equal to what will be the coordinates of this point. Now see over here, the y coordinate will change, but the x coordinate, that will remain the same, right? The x coordinate of this point and this point, any point on anywhere this line, where this line is, the x coordinate will be the same, right? So the y coordinate is going to change. So the x coordinate remains same, right? So if this is the y coordinate, this y coordinate, what is the y coordinate for this? If this is positive y, this is negative y, right? If this is positive 2, this is negative 2. If this is positive 2.5, this is negative 2.5, because this distance is equal to this distance. So the coordinates are going to be x comma minus y. What are the coordinates of this? X comma minus y, reflection of x-axis, right? Now tell me, if this point P, we had to find its reflection in y-axis, what would we do? Again, y-axis is a straight line, right? So we just take our scale and we measure this distance, okay, and we draw a perpendicular bisector from here, right? So what do is we just draw a perpendicular bisector from here, okay, and take it till here, right? And this point is P double dash. What is this? This is the reflection of the point in y-axis, okay? So the reflection, let's find out the coordinates of the reflection of any point in y-axis. Now tell me, the x coordinate for this point and this point would be different, right? How do you find the x coordinate? Draw a perpendicular on the x-axis. So this coordinate and this coordinate is different, but the y coordinate is the same, right? So the y coordinate remains same. Now what is the value of x coordinate? This point is towards the right of P, right of the y-axis, this much distance. This point is the same distance towards the left. So if this is y, this is minus y. Sorry, if this is x, this is minus x. This distance is x, right? And this distance is minus x. So this is minus x. So how do we find the reflection of a point P in the x coordinates? How do we find the coordinates of the reflection of the point in x coordinate? Or in the x-axis? We just reverse the sign of the y coordinate or the ordinate, and the reflection of point P in y-axis, we just change the sign of the abscissa or the x coordinate, and that's it. That is how it is done. Now next, what do we have is the reflection of this point, any point, in a line that is parallel to x-axis, okay? So let us draw a line that is parallel to x-axis first. Let's say that this line over here is parallel to x-axis, okay? And we have a point P over here, okay? So if we have to draw this point's reflection in this line, so what are we going to do? Let's say that this point is over here, okay? So what are we going to do? We just take our scale, draw a perpendicular from this point, and just take it downwards from here to here. I've just stretched the line. Now where this point is going to lie on this line that I have stretched, right? On this line. Now the distance should be equal to this. So this is the point P dash. That is the reflection in a line that is parallel to x-axis, right? This is how it's done. How do we find the coordinates? The reflection of point P in a line parallel to x-axis. Okay, this is what we're talking about, right? Now again, the x coordinate is going to be the same, right? So this is, let's say the point P is x comma y, okay? Point P is x comma y. So the x coordinate is going to remain the same, right? What is the y coordinate? The y coordinate is minus y plus 2 alpha. And what is this alpha? Alpha is this distance. How far this line is from the x-axis. This distance over here is alpha. This distance is alpha, and the coordinates of the point are, the reflection are x comma minus y plus 2 alpha. That is it. And if we draw a line that is parallel to, say, y-axis now. Now let's imagine that we don't have this line. Okay, we don't have this alpha. I'm just changing the figure a bit. Okay. Now let's say that we don't have this point P over here. Okay. Let's say now that we have a line that is parallel to y-axis. Okay. And this is that line. This is the line that is parallel to y-axis. Okay. Now what we have to do is we have to find the coordinates of the reflection of a point that are in a line that is parallel to y-axis. So this line is parallel to y-axis, and we have to find the coordinates of the reflection of this point. Say this point is over here, okay? So what do? We just take a scale, keep it over here, and draw a perpendicular bisector from, I'll just draw this line first, okay? And now what we have to do is we have to measure this distance and move this much this side. So this is 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So this is the reflection of the point. Say this point is P and it is x comma y. So this is P dash. Okay. So the reflection of a point in a line parallel to y-axis. Now if you see, the y coordinate again is going to remain the same, because this distance is equal to this distance, right? So the y coordinate is going to remain the same. So I'll write comma y. We have to find the x coordinate. The x coordinate again will be minus x plus 2 beta. And what is beta? Beta is this distance, the distance of this line from the y-axis. Okay, the coordinates are minus x plus 2 beta comma y. That is how we find the reflection of a point in x-axis, in y-axis, in a line parallel to x-axis, and in a line parallel to y-axis. Now to go through this video again, you just have to reverse the video and look at the figures again and again. Okay, and now we will be covering a few questions based on the theory that we've just done.